get started. So welcome to our CCNP class, ENCORE, appreciate it. Folks, I am going to offer an ENA RSI class in the summer, which is the second CCNP class. However, it will not be free. I apologize, but I'm actually digging deep in my own ASC funds to cover people to take classes as part of the summer, or part of the spring. So I don't even know if we're going to have. We're going to probably back down on the number of people we get to send to Cisco Live this year, but it's worth it. Everybody's getting the classes they need. But if you want to take the ENA RSI, the next class in the CCNP, we will offer it, but it will not be free. I'm sorry, it's just going to be $195.50 unless I get a grant somewhere. I've given away free classes for actually it's been almost 1 year that we've been giving away free ITC classes. So hopefully you've been able to get those that you wanted and needed, and we'll try to do as much as we can, but we won't be able to do it in the summer. We are looking today. I want to talk a little bit about it's $195.50 whether you're in state, out of state, no difference. It doesn't matter where you live. It is $195.50 US. So believe it or not, we do have people from other parts of the world, and it is definitely a steal. Yeah, it's very cheap. I have run across an issue. We had a student who was from trying to think, not Cambodia. I think it was from Vietnam, and had an issue where, and it wasn't in one of our Cisco classes, it was in one of our IT Academy classes, which are also $195.50. But the illness came up and he had to drop, and he sent a thing back asking if we could figure out a way to help him for the next class, and we figured out a way to help the person. But you start thinking $195.50 US is not much for us, but for him in Vietnam, it was like 4 months' salary, 4.5 months' salary. So we figured out a way to help him. But still, yeah, we will offer the classes. We will have CCNA 1, 2, and 3. We'll have CCNP, we'll have DevNet, and we'll have CyberOps all in the summer. They will be $195.50. So if you are looking for any of those, or you know anybody looking for them, we will have them. I want to talk today about first, just an overall discussion, just quick, all of us get together. Let's talk about spanning tree. So what is spanning tree? Not multiple spanning tree. I've got the multiple spanning tree up here, but what is regular old spanning tree? What's the purpose of regular old spanning tree? So we're just talking about STP, good old spanning tree. And I know there's multiple different versions. There's RSTP, there's old STP, there's previous versions of STP, but just when we talk about the spanning tree protocol in general, what problem are we trying to solve, or what are we trying to stop?
Layer 2 loops.
Layer 2 loops, right. So when we want layer 2 redundancy, we want that layer 2 redundancy, man, I can't spell that. But we don't want the loops, because the loops, remember, if you look at a frame has no TTL. There's no, in a normal frame, there's no TTL. So if it starts looping, it stays there forever. So spanning tree was developed to be able to create a loop-free path, but also the ability for that path to be modified or changed based upon the state of links between switches. We also know that all of the versions pretty much of spanning trees so far that we have discussed has been a single instance of the spanning tree for all VLANs. Okay, so if there's 10 VLANs, it was one spanning tree for all 10 of them. Excuse me, take that back. There was an instance for every single one of them. So if you had 10 VLANs, you had 10 instances. Now, the problem with that is you can end up with an environment where you've got a lot of resources going into your spanning tree. Now, it's good in some respects because, again, you can have this router as the primary route for a spanning tree of 10, 20, and 30. This one for 40, 50, 60. But you still had each individual VLAN had its own spanning tree, which can create big issues when it comes to large environments with large numbers of VLANs. So Cisco developed this multiple spanning tree. So it uses the same concept as a spanning tree. So it's still just a standard, but it's, let's see, let me get this down here. So let me get this where we can see it. So the standard was support only one spanning tree instance for an entire switch network, which means that you couldn't load balance, you couldn't block specific VLANs, you couldn't put them together. With MST, or multiple spanning tree protocol, you can map one or more VLANs into a single STP instance. So we had an instance for every VLAN. Now we're going to be able to take and say, instead of having one for every VLAN, let's take VLANs 1 through 4. Let's group them together as a common spanning tree. And let's make that one instance. And then that way we can tune the traffic of what should traverse switches, what shouldn't. If a switch doesn't have a particular VLAN, we can just take it completely out of that particular spanning tree. Here we see per VLAN spanning trees, PVST. If there were 4 VLANs, we would have 4 spanning trees. Now, that's not a big deal if we only have 4, but if you have thousands, that can become a huge burden on the processors. So I misspoke to begin with. Remember, our earlier versions were all 1 spanning tree instance per VLAN. Okay. So we're going to change this. We're now going to do it, and we're going to map it to where we can have what are called multi-spanning tree instances, or MST instances. We could do it, put VLANs 1 and 2 as an instance. VLAN 3 is its own, VLAN 4 is its own, or we could group all 4 together, just depending on what we want our environment to be. So an MST region, it's called a region, you give it a name, you then group multiple different VLANs together, and that becomes the region within which a route will be elected, a route paths will be created, a spanning tree will be developed, and it will be developed for that region. The other thing that's interesting is to other instances of spanning tree, that instance or that region will become or will look like a single switch to the other switches. So it's a way of really limiting how much the other switches have to see. So MST uses a special instance called 0, which is that internal one. It must always be the first instance, and it runs on all interfaces in the MST region, regardless. There can be up to 16 different instances by default. Depending on the iOS, you can change that slightly. Let me show you how easy it is. Now we're going to look, here's the steps, but I'm going to show you my document down here. Makes it a little bit easier to see how we do this. Okay, so MST configuration. First thing you do is by the way, the revision number doesn't automatically increment. So one of the things you got to realize, if you change an MST instance and you add VLANs to it, you have to change the revision so that it will change the MST region. But you do spanning tree MST configuration. You give the region a name, give it a revision number. So for every time you update it, if you add something to it, you need to change that revision number. And then you set what VLANs are part of that instance. Okay, so VLAN 2 and 3. So in this case, this is the one where I've created one instance that has VLANs 2 and 3 as one common spanning tree, and VLANs 4 and 5 as another common spanning tree. I've also set this particular switch to have different priorities for those different instances. So it's a grouping of spanning trees together. Okay, so go back down here, move this. So you define the spanning tree protocol by going into it, spanning tree mode MST. So we change from PVST or RSVP to spanning tree. We create either a priority number or using this route, and that's how you can change the priority. And remember, what's the purpose of the priority? Does anybody remember? Anybody remember what's one of the first things that happens in a spanning tree?
the root bridge election process.
Exactly. And what did I tell you? Do you remember what I told you about the root bridge? It's typically the priority, which is 32.768 plus the VLAN ID, dot the MAC address. And what wins? Is it the lowest bridge ID or the highest bridge ID that becomes the root? Anybody remember the little thing I told you? Explain. Lowest. Tell me you're right, lowest. Because remember, I told you, if somebody put a gun to your head and said, you've got to go jump off a bridge, but you can pick any bridge you want. I'd find a bridge that's about 2 inches off the water and jump off of it. No big deal. So we want the lowest bridge ID. This is setting that so you can control who is the root of your multiple spanning tree instance. Okay. By default, once you turn on MST, all VLANs are associated with instance 0. Okay, so if you don't change it, they all become part of instance 0. But we want to change that and move them out to different instances. So here's an example of instance 1 contains VLAN 10 and 20, and instance 2 contains VLAN 99. So when you do show spanning tree, you would see 3 different spanning trees. There'd be one for MST 0, so instance 0. There'd be one for 1 and one for 2. So you would actually end up with a root for 1, a root for 2, and a root for 0. Okay. Now we do use a region name typically. That's an optional item, but it's easier for us to be able to get them to keep up with where they're at and what they're doing by using a region name. Show spanning tree MST config, and you can see here it tells you by default all of the VLANs are mapped to instance 0. But you also, if you start moving things out, you would see other instances here. So again, we can do port cost and priority, which is a changing. Remember, we elect our route, then we find our best route path, and that's by cost to the route. We can change those items. We also, if we have 2 paths that are the same cost, we look at the port priorities. We can change those just like we could in the other versions of spanning tree, no different. But the example here is it's just inside of MST that we can do that. So here's changing the priority, or the priority's been changed from the default of 1 to, in this case, 6 and 5. Well, actually, by default, it is actually set to 128 dot the port number and lowest wins. So typically lowest wins. Here's a case where port gig 105 has been changed to a priority of 64 so that it would be preferred over the other 2 ports as a designated port. Okay. So common misconfigurations, VLAN assignments to IST, putting them in the wrong instance, and trunk link pruning. In other words, what happens many times, and that's one of the things I've got down here in my little notes that I set up for you. Very common in MST to get in trouble with your trunk ports blocking individual VLAN trunks or individual VLANs. So if you're running MST, it's highly recommended that you allow VLANs on the trunks, all VLANs. And so don't do, switchboard trunk allowed VLAN. Don't set VLAN blocking using that command if you're running MST. Leave all of them on. Okay. Also, never allow access connections between your switches or run MST on access ports between switches, because that can cause problems with the regions disappearing. And then last but not least, make sure that your trunk ports aren't pruning VLANs. So it's also, you'll notice there, do not map VLANs to MST 0. We try to map them, even though they're mapped by default to MST 0, we typically want to map them to an instance that we are controlling so that we have complete control over who's the root, what the paths are, and all of these. The beauty though is instead of a multiple, you have 10 VLANs, you don't have 10 instances of spanning tree running. A link goes down, think about that. A link goes down, you could have 10 different versions, 10 different instances of VLAN, a spanning tree, all having to reconfigure. Use MST, one spanning tree can be set up with all 10 VLANs, okay? Here's an example of setting the priority on a port, spanning tree MST. You also notice that most of these commands are just spanning tree MST. And you can set the priority. Root bridge, same thing, lowest root path cost, lowest sender bid, and then lowest port ID. 128's default, lower is better. You're setting MST cost on an interface. So you can set the cost. Now, if you start changing costs, make sure you understand exactly what you're doing. You are wanting to be very careful because you only want to change the cost if you know that you're creating the correct path. Otherwise, you can get some really weird things happening in your spanning tree. All right. Let's see here. I need to go back to right here. Okay. Again, pruning. If you end up with pruning, you can actually have a VLAN prune that's part of an instance and it will disappear. And that can cause a lot of trouble. If you do prune, only prune all the VLANs in the same MST instance for a trunk link. So everything I've read says don't prune VLANs. Allow all VLANs on all your trunks, and then you cannot get yourself into trouble. It is a boundary. So if you connect to any other type of spanning tree, it says here they never interact outside the region. They can detect the PVST plus neighbors and regions, but there's a lot of trouble when you put these together or put two regions together. You typically do want, if you do put them together, you want the MST region as the root bridge. Look right here, see, so basically, if you end up with a region, so this is an MST region, and then there's another spanning tree region. Remember, that region will appear as a single bridge to the other part, the other region. You'd want that entire region to be the root bridge. So that way you don't have all of the traffic going down through another root bridge and then up. It would be controlled and go through the multi-spanning tree region. This is, for the exam, this is a key topic is configuration of MST. So this is one of those items where you must know how to do it on the exam. So it's not enough just to know that multiple spanning tree is putting multiple VLANs together to create a common spanning tree. You must know how to actually configure it. So that spanning tree mode MST, and then setting exactly what I said over here in our document. So that's why I created this little document here. So you can see, come on, exactly how you do it. So, and this is in our notes. You'll notice it's in our class notes. If you look on the page down here, 1 through 5, I put it right down here at the bottom, MST notes. So you've got it available, you can use it, but it goes through what and how to configure MST. So spanning tree MST config, name, there's your region name, revision, instance 1, and then map VLANs 2 and 3, and it can be any number of VLANs. And then you can also set it as the root for that particular instance. And that would make, if you're doing this on a switch, that would make this, if you do root primary, it would make this switch the primary for that particular common spanning tree. Or secondary, depending on how you set it. Questions about multiple spanning tree. You need to know how to configure this. Our weather alert. Oh, maybe not. Okay. Any questions on that? All right, let's look then at my next item, which was downloads. Oops. That was chapter 4. Now, chapter 5 is talking about VLAN trunks and Ether channel bundles. Most of you are aware of DTP already, which is Dynamic Trunking Protocol. We used to cover VTP a huge amount inside of CCNA. We don't do that anymore, but we are going to talk about VTP. VTP is a way of creating VLANs once and having them propagate down throughout your environment. VTP servers and clients, basically a switch can have one of 4 roles. They can be a server, which has a read-write version of the VLAN database. It can be a client, which has a read-only version of the database. It can be transparent, which means they pass VTP information but don't participate in it. Or they can be off, which means they don't participate in VTP at all and they will not pass VTP information. Now, 3 versions, 1, 2, and 3. Version 3 is the most current version and does allow through VLANs 1 through 4094. You can have multiple different versions in a domain, but I typically tell you to, if you're going to use a single version, use the same version on all your switches. What you typically do is you create your VLANs on your servers and then they propagate down to your clients. As long as your VTP domain names are the same and the versions are the same or backwards compatible, then you are able to pass those around. So let me see if I can get this going here. I'm going to start Packet Tracer up and give you an example here in just a second. But first off, we'll define our VTP version. We'll set our domain name, set our mode. By the way, by default, the VTP mode is server, and then we can set an optional password if we want to do so. So here's an example of setting a VTP domain name of Cisco Press, a mode of server, and setting this as VTP primary for future VLANs. And then we can change the version if we so want to. So let's see what we can do inside of Packet Tracer here. Let me sign in real quick. Why do you think this would be useful? Why is it useful to be able to, instead of having to touch all, let's say you have 40 switches and 30 VLANs, wouldn't that be a bit of a pain trying to create all those VLANs? Or especially what if you need to make a VLAN change? Need to add a VLAN. You have to go touch all 30 switches. So let's imagine we're going to pull out 2960 and 2960. And now there's one important thing that I want you to note. All right, so let's go back over here. Oop, not this one. Wrong one. Go back over here. What is the name of this protocol? VLAN trunking protocols. You must set trunks between your devices for it to work. Okay, so let's go in here. We're going to connect these two. We're going to connect gig 01 to gig 01. We'll go into this switch, CLI, in config T, host S1, not SQ, SW1 or S. Yeah, I cannot type, folks. SW1, int G01, switch port, mode, trunk. That's all we'll do. We'll go to the other side here. CLI, en, pt, host SW2, int G01, switch port, mode, trunk. All right. I'm going to go back up one. I'm going to go VTP version 3. See, it won't even support 3 inside of Packet Tracer. You can only do 1 to 2. So let's just do VTP version 2. Actually, let's just leave it at 1. Let's not even change our VTP version. Let's do VTP mode client. We'll make this a client. Okay. VTP password is going to be Cisco. Okay. VTP, got to set my domain. Domain is going to be capital VTP underscore example. Okay. Then I'm gonna set my password. All right. So let's go in here now. We're gonna do VTP mode server. VTP, notice it says it's already a server because that's the default mode. VTP domain, VTP underscore example, VTP password, Cisco. Now let's do show VLAN, and let's see how many VLANs we have on here. We have no VLANs have been created. That's on switch 1. Let's go over to switch 2. All right. Do show VLAN. There should be no VLANs here either. All right. But now I'm gonna go to my server and I'm gonna go VLAN 10 name management. VLAN 20 name students. Students. Yeah. Up arrow because I'm lazy. VLAN 30. I mean efficient. And faculty. Exit. Do show VLAN. We should see 10, 20, 30. If I go over here, I should better do a do show VLAN. And notice how automatically those 3 VLANs were added to my client. Yep. So much easier. You've got scaling, the ability to easily add VLANs. Now notice it does not put ports in the VLAN. So you've only created the VLAN, you haven't added any ports to it yet. So this doesn't add ports to VLANs automatically. It just creates the VLANs across your environment. So if you had more clients connected, those clients would continue to get those VLANs. So if we had another trunk here, so we had another switch. Okay. We had another switch here, and we added an additional trunk link. Oops. So we went from gig 02 to gig 02. And we went in here and we did int G02. Now remember, because it is VLAN trunking protocol, switch port mode trunk, get trunk in here. Let's go down here to gig 02 on switch 3. This will be en host, config T first, config T host SW3. We're going to go into int G02. Switch port mode trunk. Okay. We're going to do VTP domain, VTP underscore example, VTP password, Cisco, VTP mode client. Do show VLAN. And look what just happened. It immediately picked up those VLANs. So if I go back to my server, I do VLAN 99, name test, VLAN 999, name black hole. So that VLAN, you want to park everything, or let's just name it parking. We'll name it parking. So it's parking VLAN. Exit. Exit. Now we can go over here and we can look at, we'll show VLAN here. Now we got 10, 20, 30, 99, and parking. And then on down here, we can do the same thing again. And lo and behold, all the VLANs are created. So super easy, great tool, makes life easier for us and our networks. Now, let me give you the caveats and the dangers. Okay, here's the major danger. So imagine you're playing with switches in your environment, your network, especially in a test environment. You're using the same name as your typical, as your actual campus network, and you are trying to just do some testing. So you're testing with it. You keep playing around, keep adding, you know, on the primary switch, you keep adding items. So, sorry, y'all. All right, keep adding items, keep adding switches to everything. And then you take that switch without rebooting it and without clearing its config and connect it to your campus network. The problem with that is you can actually overwrite all of the switches, because you'll see this configuration revision, which is 10. If the revision number on the switch you've been using in your test environment is higher than the server on your production network, it will overwrite all the VLANs. There have been instances where people were playing in the lab, had all the VLANs just all kind of messed up, connected that to a production network, and suddenly erased all the VLANs in their entire environment. So be aware, that can be a huge issue. The way to fix it is you make sure that you erase the configuration and you reload the machine, you turn it off, turn it on before you ever put that switch into your environment. Otherwise, massive problems. So be aware of that. Questions about BTP? None? Okay. DTP, I'm not going to spend a lot of time on because we talk about it in CCNA. So it's just dynamic trunking protocol. And I'm not going to spend much time on Ether channel because we do Ether channel in our CCNA. Are there any questions on Ether channel? Remember, it's just a way to aggregate multiple links together. The links have to be the same speed, the same type. It's really good though, because then they become, for spanning tree, they appear to be a single physical link instead of multiple links. We also have started doing things with LACP and PageP, but we also have, we do aggregate links like this to our server. So it's not just between networking devices now. Remember that PageP is a Cisco proprietary. Remember that about proprietary, PageP, proprietary. LACP is an open standard. Okay. Questions about Ether channel? Everything good? Show Ether channel summary. All of these, so showing here different types of things you can do with Ether channel. Minimum number of port channel interfaces, maximum number. And remember, they have to be the most common types of problems you have with Ether channel is the fact that you end up with different types of interfaces. I'll show you something else. Maybe I hope I can see if I can get it to work here. If I get my whiteboard to work. Your whiteboard. Yeah, let's see if I can. Well, that didn't work. Hold on. I get a whiteboard to come up here. We'll pull this app up just a second because I want to show you something real world that's important. Give it a second, folks. Takes a little bit for it to open up. Can't really do this with Notepad. I'm pretty much killing my machine right now because I got so much stuff open. Even though this laptop's pretty hefty, it's not the world's fastest. I'll show you a real world consideration with Ether channel. I think I've already showed you this, but I want to make sure I show it to you again so you're aware. Yeah, you're right. Exactly. Guess I'm gonna open a new whiteboard here. Also doesn't help that I've got 6,000 different whiteboards. All right, so let's imagine we've got a switch here. All right. I'm gonna connect it with another switch to an Ether channel. So I've got these ports. Got ports here, 1, 2. There's 3, 4. I know my handwriting's terrible, but it is what it is. I'm trying to do this on 4, 5, 6, 7. I'm just going to do 8 ports. 2, 3, 4, 5, 6. Okay. One thing you're going to learn in the real world is about ASICs. Now, I mentioned these before, but what are ASICs? They're not shoes, although that is a type of shoe, and that's the type of shoes I wear. But ASICs are application-specific integrated circuits. Switches use ASICs to control ports. So what you will learn is many times switches are divided into port groups that are controlled by a specific ASIC. So this may be controlled by an ASIC, and then this one over here may be controlled by a separate ASIC. Now, this is getting deep in the weeds into database, or not database, but data center configuration. But what we have learned is, because we want the most redundancy we can have, it's actually possible for, on a switch, one ASIC to die and a set of ports to quit working. Okay, and a set of ports to quit working while the other ports keep working. So if we were going to create an ether channel between these two switches, the safest thing to do would be to use one link in this ASIC group and one link in another ASIC group. Now that would create a port channel. That would create an ether channel right there. But if ASIC 1 died, the port channel would stay up. Likewise, if it continued on, let's say you had 48 ports and you wanted to put 4 ports together in an ether channel, you would want to pick a port out of each, 4 separate ASIC groups. So you can actually look on your switches and read about what ports are assigned to what ASIC groups. And then that gives you even better redundancy in the real world. So be aware of that, a lot of people would just take it and immediately just put these 2 ports right here together. Well, if this ASIC croaks, you've lost your entire ether channel bundle. But if you spread it across the ASICs, then you don't have to worry about it as much. All right. So that's a real world example of how you can take ether channel and the ASICs or the hardware of your devices and increase the ability of it to be even more redundant than what you would normally have. Okay. Now, other things you can do is this. You can actually load balance across your port channels. Depending upon, by default, there's a bunch of different options that are available. And what you need to do is you need to learn that you can change the load balance hash. If you don't, it may be, even though you've got 4 different ports in your ether channel, all of them actually end up going across one link. So you can actually change the port channel balance hash, load balance hash. I've looked this up before, but I'm pretty sure it's source destination IP or source destination MAC is the default. But let's see. So show you the channel load balance will show you. Let me do a quick, almost real quick. Let me do a quick for LACP. Default. One second, I'm looking at the default is source MAC. So, okay. So the default is source MAC. And so if you look at this list for LACP, get back in here and get my share going again. For LACP, the default is source MAC. Okay. So be aware, you may want to monitor your traffic and make sure you see what's actually going on. You may want to change that depending on how your traffic is flowing across your port channel. But you can change it. Show you the channel load balance will show you what is being used, and you can change that. Now, one of the things about it is because it is a binary function, your links should really be in powers of 2. if you do odd numbers, the load balancing can really get into some weird situations where it won't even use an entire channel. So if you do 3, it may not load balance across that third link at all, no matter what you do. So be aware, try to be consistent and use 2, 4, 8 in terms of your links on either channel. You notice it says if a port channel is established with a router using a MAC address as part of the hash, can impact traffic flow to a router's MAC because it doesn't change. So a better choice if you're connecting a Ether channel to a router would be to use source destination IP addresses. So you can change it depending upon where the Ether channel, the traffic is going and how it's being used. I like this prep for the exam. It shows you the commands that are available here. And so different items you can do, channel mode, setting up either channel balance, showing that. Going back, VTP, you need to know how to configure VTP. Very simple. You saw me do it in 5 minutes. Okay. But that is our module 5. Any questions on it? Okay. All right, folks, that's all I got for today. Are there any other questions on what's going on? How many of you are going to be at the meeting tomorrow? Anybody? I see John raise his hand. Or John's going to be here. I know a lot of you are remote. We're going to try to record it and also try to stream it live. I sent that link out. Can't promise it'll work, but we're going to try to do it. So just be aware we will be trying to make it happen tomorrow. Okay, good. So Hill's here. Good. That'll be good. When do you sign up for the NARSI? It'll be a month or so, or at least a month before we have the ability to sign up for the summer NARSI class. So I'll let everybody know as soon as it's up and ready to go. We haven't created the classes yet, so we can't take registration yet. But as soon as we do, we'll let you know. All right, I'm gonna stop recording.